Okay, perfect. So first few minutes today, we'll go through some slides, and then we switch to data architecture interview questions. So this first slide just talks about cross-cloud architectures, and Google has a platform called Google Antus, which is Kubernetes based, which allows to run applications between clouds and also on premises. And they use this, for example, to do something called BigQuery Omni, which is just a second, I'll stop my video here, which is how you can, from BigQuery, which is their main database, you can query data sources on other clouds or on premises. Azure has similar system called Azure Arc, similar to Antus on Google. It also uses Kubernetes. It also allows to query different clouds and on premises. Amazon doesn't have anything like that. Amazon has AWS Outposts, where they provide hardware. So you see this rack, which they install, and this is kind of a cloud on your premises, but it's a part of Amazon cloud. Okay, let's go next slide. Next slide is, yeah, it's a BigQuery Omni, which I just mentioned, which is based on, works on top of Antus. Okay, next slide. Next slide is, yeah, these are Azure updates. I think I went over them on the previous seminar, and one of the updates is Azure Arc. You see here on the left, unify on-premises, hybrid, and multi-cloud infrastructure with Kubernetes-based deployment. Okay, next slide. SQL Server 2022. So many changes were announced, but the main theme is that on-premises SQL Server now can communicate with the cloud, can back up to the cloud, migrate to the cloud, and so they connected on-premises and cloud Microsoft SQL Server, which is good. And there are also some security upgrades, like using blockchain and so on, and performance updates, like they can store multiple plans per store procedure. I mean execution plan for SQL, so multiple plans. Okay, next slide. Apache Flume, well, this is the system to process a large amount of data, mostly log files, and whatever, just for you to know that it exists, and it's a good system and it's open source. Next slide. Next slide is very important. Azure just announced a preview of something which is called Azure Data Explorer. So what they did, they took their existing system, which was created in 2014 and which used to be called Kusto, and they now integrated it into Synapse. So Kusto existed for many years. It was named after Jacques Cousteau, a very famous French ocean explorer. So we're talking about oceans and the inhabitants, like sharks or whatever, right? So they're thinking about ocean of data, and that's why they call this project Cousteau. And they have their own language called Cousteau Query Language, which is similar to SQL, but it also allows you to use pipes, like vertical pipes, like in Unix. So you can take output of one query and pipe it into another query and another query. It also allows you to use regular expressions. It allows to parse text fields and also time series analysis, because log files may have information stored like sequentially in time, and sometimes you want to analyze those patterns. So it's a very powerful and scalable system which Azure had, and now they included it as part of the Synapse, and it's called Azure Data Explorer. So when it runs, it needs servers, it needs nodes to do the queries. So now we have Azure Data Explorer pool in Synapse. So we have dedicated pool, which is data warehouse. We have serverless pool, which is SQL querying of files. We now have Azure Data Explorer pool. And of course, we also have Apache, not Apache, but PySpark pools. So different kinds of pools in Synapse. Next one. Okay, this is about Apache Presto. At Facebook, they use Presto as a data warehouse. So Presto was developed at Facebook, and then they moved it into open source. It's similar to BigQuery. So compute nodes are separated from storage, and storage may be of different types. So here I listed Hadoop, Cassandra, Kafka, S3 buckets, and whatever, MySQL, MongoDB, Teradata. And they all can be queried, and the queries can use joins between those different types of data. So it's a very powerful database. Amazon Athena is simply a hosted version of Presto. So it's again, we have BigQuery at Google, which is distributed database. We have Amazon Athena. We have Presto at Facebook. Azure Cloud, as far as I know, doesn't have system like that. Synapse data warehouse is limited to one data center, so it cannot span multiple data centers. Anyway, this is Presto. Next one is just a few words about BIML. So BIML, Business Intelligence Markup Language, you see the example. It's basically XML, and you can program it, and then you can, there is a software called BIML Studio, which is kind of like a Microsoft, what is called Studio for development. And it allows you to create SSIS packages. SSIS is SQL Server Integration Services. So this is basically to automate creating those packages for ETL, extract, transform, load. Powerful, but maybe outdated, because I really don't like to write my code in XML. I would prefer at least JSON or YAML or maybe Python, but it exists and it's a good tool. Okay, Misha, let's stop that and let's switch to you and to interview questions. Okay.
Okay. All right, and we are down here
on page 39, I think.
Big data.
Yep. No, hold on. There was one question above. Oh no, we finished it, right? 17. Okay. Okay.
All right. So, and we are going to go through this section today and hopefully the one after. How do you approach data preparation? Data preparation is one of the crucial steps in big data projects. We need to make sure that data is processed carefully and fully to prepare for modeling. You can discuss the types of models, analytics you are planning to use. You should also discuss typical data preparation steps, including handling nulls, zeros, missing data, outlier values, converting data types, strings to numbers or dates, unstructured data, identifying gaps and filling them in, etc. How to restart all the daemons in Hadoop. Daemons are processes that run in the background. Hadoop has 5 such daemons, each running in its own Java virtual machine. A name node, a secondary name node, a data node, job tracker, task tracker. And so to restart all the daemons, there are the following commands. Explain the term commodity hardware. Commodity hardware refers to the minimal hardware resources and components collectively needed to run the Apache Hadoop framework and related data management tools. Apache Hadoop requires 64 to 512 gigabytes of RAM to execute tasks, and any hardware that supports its minimum requirements is known as commodity hardware. Explain some important features of Hadoop. Hadoop allows to store and process data distributed over thousands of servers, called nodes. Hadoop is an open source framework, Apache Hadoop. It is free. Users are allowed to change the source code as per their requirements. Hadoop uses HDFS, Hadoop Distributed File System, where you can access data in all nodes. MapReduce, you send map a request to all servers. They process the data in parallel, send the responses back. where they are received and reduced. Fault tolerance / reliability. Hadoop creates 3 replicas for each block of different nodes by default. So we can recover the data from another node if one node fails. The detection of node failure and recovery of data is done automatically. Also, failed nodes can be automatically replaced in real time. Scalability. We can easily add the new nodes and new hardware to the nodes. High availability. The data stored in Hadoop is available to access even after hardware failure. In case of hardware failures, data can be accessed from another path. Hadoop uses files, typically CSV, JSON, and Parquet, to send data between nodes. File operations are slow. Apache Spark achieves much faster performance by decreasing temporary file operations and sending data directly via networks between node servers.
Misha,
How can you achieve?
Misha,
Yes.
Can you please change the word JSON, remove the O?
Oh, yeah.
Yeah.
This one. All right.
No. Yes, Java. Hold on.
JavaScript object notation. So.
You're right. Okay, good.
he did the pronunciation version of the spelling.
Right.
How can you achieve security in Hadoop? Kerberos security is typically used. Here are 3 steps to access service. Authentication of the client to the authentication server, getting a time-stamped TGT, a ticket granting ticket, to the client. Authorization, getting the service ticket, and use the service ticket to request the service. Why do we need Hadoop for big data analytics? In most cases, exploring and analyzing large unstructured data sets becomes difficult. With Hadoop, you can analyze large amounts of raw unstructured data in parallel on multiple nodes. Since Hadoop is open source and is run on commodity hardware, it is also economically feasible for businesses and organizations to use it for big data analytics. What are the edge nodes in Hadoop? Edge nodes are gateway nodes in Hadoop, which act as the interface between the Hadoop cluster and external network. They run client applications and cluster administration tools in Hadoop and are used as staging areas for data transfers to the Hadoop cluster. Enterprise class storage capabilities like 900 gigabyte SAS drives and RAID HDD controllers is required for edge nodes, and a single edge node usually suffices for multiple Hadoop clusters. What is MapReduce? The name MapReduce originally referred to the proprietary Google technology, but has since been generalized. It is a core component of Apache Hadoop. MapReduce is a software framework and programming model used for processing huge amounts of data. MapReduce works in 2 phases, namely map and reduce. Map splits the tasks between many nodes, and reduce shuffles and reduces the data. MapReduce basically facilitates concurrent processing by splitting petabytes of data into smaller chunks and processing them in parallel on Hadoop commodity servers. In the end, it aggregates all the data from multiple servers to return a consolidated output back to the application. What is big data analysis? How is big data analysis helpful in increasing business revenue? Big data analysis helps businesses to differentiate themselves from others and increase their revenue. Predictive analytics provides businesses with customized recommendations and suggestions, enabling the launch of new products in accordance with customer needs and preferences. Companies may encounter a significant average increase, 5 to 20% in revenue, through proper application of analytics. Just about any big name corporation is using data analysis to further its goals: Walmart, LinkedIn, Facebook, Twitter, Bank of America, etc. What are the common input formats in Hadoop? Text input format. The default input format defined in Hadoop is the text input format. Sequence file input format. To read files in a sequence file input format is used. Key value input format. The input format used for plain text files broken into lines, is the key value input format. How is NFS different from HDFS? NFS, Network File System, is one of the oldest and popular distributed file storage systems, whereas HDFS, Hadoop Distributed File System, is the recently used and popular one to handle big data. The main difference between NFS and HDFS are as follows. NFS does not have any built-in fault tolerance, whereas HDFS was designed to survive failures as it has fault tolerance or replication. HDFS's storage capacity is comparatively high. What is the use of JPS command in Hadoop? The JPS command, Java process status, is used to check if the Hadoop daemons are running properly or not. The command shows all the daemons running on a machine: data node, name node, node manager, resource manager, etc. What will happen with a name node that doesn't have any data? A name node without any data does not exist in Hadoop. If there is a name node, it will contain some data. Define big data and explain the 5 V's of big data. Big data is defined as a collection of large and complex and structured data, which can be used for analytics, modeling, and deriving insights using tools like Hadoop. The 5 V's of big data are volume, amount of data in petabytes and exabytes; variety, includes formats like videos, audio sources, textual data, etc. Velocity, velocity refers to the high speed of accumulation of data. Veracity, it refers to inconsistencies and uncertainty in data. That is, data which is available can sometimes get messy, and quality and accuracy are difficult to control. And value, deriving insights from the collected data to achieve business milestones and new heights. Define and describe the term FSCK. FSCK, file system check, is a command used to run a Hadoop summary report that describes the state of the Hadoop file system. This command is used to check the health of the file distribution system when one or more file blocks become corrupt or unavailable in the system. FSK only checks for errors in the system and does not correct them, unlike the traditional FSK utility tool in Hadoop. The command can be run on the whole system or a subset of files. Explain the different features of Hadoop. Some common prominent features are as follows. Open source. It's an open source framework, includes source code that is available and accessible by all over the World Wide Web. The code snippets can be rewritten, edited, and modified according to user and analytics requirements. It is scalable. Although Hadoop runs on commodity hardware, additional hardware resources can be added to new nodes. Data recovery. Hadoop allows the recovery of data by splitting blocks into 3 replicas across clusters. Hadoop allows users to recover data from node to node in case of failure and recovers tasks/nodes automatically during such instances. It's user-friendly. For users who are new to data analytics, Hadoop is the perfect framework to use, as its user interface is simple and there's no need for clients to handle distributed computing processes, as the framework takes care of it. Data locality. Hadoop features data locality, which moves computation to data instead of data to computation. Data is moved to clusters rather than bringing them to the location where MapReduce algorithms are processed and submitted. How does HDFS index data blocks? HDFS indexes data blocks based on their respective sizes. The end of a data block points to the address of where the next chunk of data block gets stored. The data nodes store the blocks of data, while the name node manages these data blocks by using an in-memory image of all the files of said data blocks. Clients receive information related to the data blocks from the name node. What do you mean by speculative execution in context to Hadoop? In certain cases where a specific node slows down the performance of any given task, the master node is capable of executing another task instance on a separate node redundantly. In such a scenario, the task that reaches its completion before the other is accepted, while the other is killed. The entire process is referred to as speculative execution. What is the process of record reader in Hadoop? The input split defines a slice of work, but does not describe how to access it. The record reader class loads the data from its source and converts it into key value pairs suitable for reading by the mapper task. The record reader instance is defined by the input format.
Isha, it's a record reader. Hello?
Record reader?
Yeah, a record. It
Yes.
reads records.
Yeah, right. Yes, I read that a little, like tomato reading, right? So record reader, not record reader. What are the components of Apache HBase? Apache HBase began as a project by the company PowerSet in 2008. It was mimicking the Google search big table architecture and used to process massive amounts of data for the purpose of natural language search. Since 2010, HBase is a top-level open source Apache project. Facebook used HBase in 2010 to 2018 for their messaging platform. HBase has three major components. Region server, a table can be divided into several regions. A group of regions is served to the clients by a region server. HMaster, it coordinates and manages the region server, similarly as name node manages data node in HDFS. Zookeeper, a zookeeper acts like a coordinator inside HBase distributed environment. It helps in maintaining server state inside the cluster by communicating through sessions. So that is big data. Now this next section, working with others. What challenges have you faced working with colleagues with no technical background? How did you address and overcome these challenges? Data architects often work with other departments within a company that involves collaborating with people who lack technical background and understanding of the data processes. The interviewer would like to assess your communication style and your ability to reach common ground with your coworkers, in spite of your differences. Describe a specific situation to illustrate the issue you encountered and how you solved it. So here's an example answer. I believe a good data architect should understand the needs of the different departments across the company. That said, I've had to work with people who don't fully understand my role and responsibilities on numerous occasions. Some of my coworkers would pose requests that I had to reject due to our data architecture limitations, and that has led to certain tensions. I'd say overcoming such challenges takes time. Gradually, we learn more about each other's work, which helped us brainstorm possible solutions. All in all, making the extra step to educate myself and the others has made all the difference. How would you resolve a conflict between your team? So how to answer. The hiring manager wants to hear about your ability to professionally solve team issues when they occur. Think of an example where you had to use your communication skills to handle a conflict with your coworkers, or when you managed to help two of your teammates find common ground as a mediator. An example answer. I like to think I have excellent conflict management skills. As a data architect in a large company, I've worked in a high-stress environment. That has sometimes caused tensions to build up among team members. When this escalates to a conflict, I try to deal with it openly. Usually, I'd organize a group of meetings where everyone can voice their concerns. This is how we can sort out the issues and move on with our work on the project. That was a bit of a short section. Now we are on Kubernetes. What is Kubernetes? Why are organizations using it? Kubernetes is an open source container orchestration system. It is used for automating computer application deployment, scaling, and management. It was originally designed by Google and is now maintained by Google Cloud, by Cloud Native Computing Foundation. Kubernetes allows you to configure your system to run applications in different data centers, even in different countries. It also provides generic primitives for health checking and replicating your application across these machines, as well as services for wiring your application into microservices so that each layer in your application is decoupled from other layers so that you can scale, update, maintain them independently. How do containers within a pod communicate with each other? A pod is the smallest deployable unit of computing in Kubernetes. A pod, as a pod of whales or peapod, is a group of one or more containers with shared storage and network resources and a specification for how to run the containers. A pod's contents are always co-located and co-scheduled and run in a shared context. Containers within a pod share networking space and can reach others on local hosts. For instance, if you have two containers within a pod, a MySQL container running on port 3306 and a PHP container running in port 80, the PHP container could access MySQL 1 through localhost 3306. What does a pod do? A pod is the smallest deployable unit of computing in Kubernetes. Pods represent the processes running on a cluster. By limiting pods to a single process, Kubernetes can report on the health of each process running in the cluster. Pods have a unique IP address, which allows them to communicate with each other, persistent storage volumes as required, configuration information that determine how a container should run. Although most pods contain a single container, many will have a few containers that work closely together to execute a desired function. Explain what are some pod usage patterns. Pods can be used in two main ways. Pods that run on a single container. The simplest and most common pod pattern is a single container per pod, where the single container represents an entire application. In this case, you can think of a pod as a wrapper. Pods can have multiple containers that need to work together. Pods with multiple containers are primarily used to support co-located, co-managed programs that need to share resources. These co-located containers might form a single cohesive unit of service. One container serving files from a shared volume, while another container refreshes or updates those files. The pod wraps these containers and storage resources together as a single manageable entity. Each pod is meant to run a single instance of a given application. If you want to run multiple instances, you should use one pod for each instance of the application. This is generally referred to as a replication. Replicated pods are created and managed as a group by a controller, such as the deployment. What does it mean that pods are ephemeral? Pods do not heal or repair themselves. For example, if a pod is scheduled on a node which later fails, the pod is deleted. Similarly, if a pod is evicted from a node for any reason, the pod does not replace itself. The term ephemeral containers used to describe a special type of container that runs temporarily in an existing pod to accomplish user-initiated actions such as troubleshooting. Pods are ephemeral. When the pod is terminated, it cannot be brought back. In general, pods do not disappear until they are deleted by a user or by a controller. Explain what is a master node and what components it consists of. The master node hosts the control plane aspects of the cluster and are responsible for, among other things, the API endpoint, which the user interact with and provide scheduling for pods across resources. It is the most vital component responsible for Kubernetes architecture. It is the central controlling unit of Kubernetes and manages workload and communicates across the clusters. The master node has various components, each having its process. They are etcd, controller manager, scheduler, and API server. Give a more detailed description of etcd, controller manager, and scheduler in Kubernetes. etcd, also daemon, a consistent and highly available key value store used as Kubernetes backing store for all cluster data. This daemon stores the configuration detail and essential values, communicates with all other components, and manages network rules and posts forwarding activity. Controller manager, a daemon responsible for most of the controllers. It collects information and sends to API server. It controls controller handling nodes and endpoints. The scheduler, one of the key components of the master node associated with the distribution of workload. It allocates pods to nodes, manages total resources available as well as resources per node. Explain when to use Docker versus Docker Compose versus Docker Swarm versus Kubernetes. So Docker is a container engine. It makes you build and run usually no more than one container at most locally on your PC for development purposes. Docker Compose is a utility to run multiple containers and let them share volumes and networking via the Docker engine features. Runs locally to emulate service composition and remotely on clusters. Docker Compose is mostly used as a helper when you want to start multiple Docker containers and don't want to start each one separately using Docker Run. Docker Swarm is for running and connecting containers on multiple hosts. It does things like scaling, starting a new container when one crashes, and networking containers. Kubernetes is a container orchestration platform. It takes care of running containers and enhancing the engine features so that containers can be composed and scaled to serve complex applications. Sort of platform as a service managed by you and cloud provider. Kubernetes goal is very similar to that of Docker Swarm, but it's developed by Google. What are namespaces? What is the problem with using one default namespace? Namespaces allow you to split your cluster into virtual clusters where you can group your applications in a way that makes sense and is completely separated from the other groups. So you can, for example, create an app with the same name in two different namespaces. When using the default namespace alone, it becomes hard over time to get an overview of all the applications you manage in your cluster. Namespaces make it easier to organize the application into groups in a way that makes sense, like a namespace for all the monitoring applications and a namespace for all the security applications. Namespaces can also be useful for managing blue/green environments, where each namespace can include a different version of an app and also share resources that are in other namespaces like logging, monitoring, etc. Another use case for namespaces is one cluster, multiple teams. When multiple teams use the same cluster, they might end up stepping on each other's toes. For example, if they end up creating an app with the same name, it means one of the teams overrides the app of the other team because there can't be two apps in Kubernetes with the same name in the same namespace. What happens when a master fails? What happens when a worker fails? Kubernetes is designed to be resilient to any individual node failure, master or worker. When a master fails, the nodes of the cluster will keep operating, but there can be no changes, including pod creation or service member changes, until the master is available. When a worker fails, the master stops receiving messages from the worker. If the master does not receive status updates from the worker, the node will be marked as not ready. If the node is not ready for 5 minutes, the master reschedules all pods that were running on the dead node to other available nodes. What is a stateful set in Kubernetes? When using Kubernetes, most of the time you don't care how your pods are scheduled, but sometimes you care that pods are deployed in order, that they had a persistent storage volume, or that they have a unique stable network identifier across the restarts and reschedules. In those cases, stateful sets can help you accomplish your objective. It manages the deployment and scaling of a set of pods and provides guarantees about the ordering and uniqueness of these pods. Stateful sets are valuable for applications that require one or more of the following: stable, unique network identifiers, stable, persistent storage, ordered, graceful deployments and scaling, ordered and automated rolling updates. What is a daemon set? A daemon set are used in Kubernetes when you need to run one or more pods on all or a subset of the nodes in a cluster. The typical use case for a daemon set is logging and monitoring for the host. For example, a node needs a service daemon that collects health or log data and pushes them to a central system or database. As the name suggests, you can use daemon sets for running daemons and other tools that need to run on all nodes of a cluster. These can be things like cluster storage daemons, Quobyte, Glustered, Ceph, etc., log collectors, Fluented, Logstash, or monitoring daemons, Prometheus node exporter, Collected, New Relic agent, etc. What is the difference between Kubernetes and Docker? Docker and Kubernetes are complementary. Docker provides an open standard for packaging and distributing containerized applications, while Kubernetes provides for the orchestration and management of distributed containerized application created with Docker. In other words, Kubernetes provides the infrastructure needed to deploy and run applications built with Docker. And I believe that we are at the end here. So we still have some minutes. I'll finish this question. Which problems does container orchestration solve? Containers run in an isolated process, usually in its own namespace. This means that by default, the container will not be aware of other containers. Additionally, it will not be aware of the file system, of the system files, network interfaces, and processes. While this can greatly help with portability of the software, it does not solve several production issues such as microservices, container discovery, scalability, disaster recovery, or upgrades. Adding a container orchestrator can greatly reduce the complexity in production as these tools are designed to solve the issues outlined above. For example, Kubernetes is built to allow containers to be linked together, deploy containers across an entire network, scale and load balance the network based on container resource consumption, and allow upgrades of individual containers with no downtime. If you are only running a single container or two containers together, you are correct in that an orchestrator may be unnecessary and add unneeded complexity. All right, guys, that's it for today.
Misha, thank you. Very good. You did it very fast, and we just have very few questions left. And guys on the call, if you can think about some questions which need to be added to this document, please email me, Misha.
Of course. It was
Right.
very nice. Thank you. It was very efficient and clear, actually.
Yeah, got a lot done today.
Okay. Thank
Yeah,
you.
thank you
Have
so
a great
much.
weekend.
Yes, you too. Thank
Have a
you,
good
everyone.
weekend.
Thank you.
Thank you.
Thank you, everyone. Bye.
Bye.
Bye.